I just need for you to shut up. 19. Otherwise you'll be bringing donuts again. you can't even bet on yourself. That's pretty bad. You can't even depend on yourself. Alright. So we have a triangle, and we'll call this A, B, and C. This is law of cosines, so therefore it doesn't really matter where you put the angles and whatnot, it all works out. Okay, so this angle happens to, and you don't have, there is no ambiguous case in law of cosines. Okay, there is no ambiguous case. It only occurs in law of sines. So that's 80 degrees. Yes, ma'am. Wrong number? Oh, never mind. Alright, start over again. 19. B is equal to 4, C is equal to 1, and A is equal to 120 degrees. Okay, another thing. If you're using law of sines, and whenever you take sine inverse of 120 degrees, your calculator is not going to take sine inverse of 120 degrees. Your calculator is going to take sine inverse of what angle? Come on. 60 degrees, because 120 is in the second quadrant and sine inverse doesn't exist in the second quadrant. So it's going to assume it's a 60 degree angle. That's why a lot of times when you're taking sine inverses and then it's 120 degrees, it's not going to give you 120 degrees. It's going to give you 60 degrees. Okay, so that's why when you're using law of sines, you got to be careful. Okay, if the angle's big, don't take sine inverses of anything that's going to give you an angle bigger than 90 degrees. Okay, save that for last. Alright, having said that, let's go ahead and solve this using law of cosines, which it doesn't really matter for us. Since I have that angle, then this is the formula I'm going to use. A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. Okay, I'm going to be solving for A because I have angle A. So this is going to give me A squared is equal to 4 squared plus 1 squared minus 2 times 4 times 1 times cosine of 120 degrees. Okay, so this is A squared is equal to 16 plus 1, okay, minus 8, and cosine of 120 degrees, that's in the second quadrant, so it's going to be negative. Okay, it's related to 60 degrees, so cosine of 60 degrees is 1/2, so negative 1/2. So I'm going to get A squared is equal to 17, and this is going to give me a plus 4. So A squared is equal to 21, A is equal to rad 21. So if I have A, B, C, if that's 120 degrees, and this is rad 21, and B happens to be 4, and C happens to be 1. Okay. Again, I can use law of cosines, and I don't have to worry about anything, but law of cosines is a mess. I mean, it just takes so much time to do this. Law of sines is much easier. Now that I have an angle, okay, 120 degrees, and then I have rad 21, I can use law of sines. Okay, so I'm going to use law of sines. Sine of 120 degrees, all that over rad 21 is equal to. Now the choice is this: which one should you solve for, the B or C? Well, you can solve for either one, but remember, you want to stay with the small angle. Okay, if you want to, you can get the big angle at the end by subtracting. Okay, adding and subtracting. The reason you want to stay with small angle because of the restrictions of sine inverse, because I'm going to take sine inverse somewhere here. Okay, so I don't get a false positive. So it's going to be sine of C is to 1. So I'm going to solve for sine C. Okay, so sine of 120 degrees, that's going to be rad 3 over 2. And that same thing is 60 degrees. Okay, so I have rad 21 is equal to sine of c. So I have a sine of c is equal to, this is over 1, that's going to give me rad 3 over on the top and 2 rad 21. Okay, so then my c is going to be sine inverse of rad 3 over 2 rad 21. So I go with my handy dandy calculator, I make sure I'm in degrees, and I am. So I'm going to go sine inverse. Okay, sine inverse, and I have a rad 3. Rad 3. I'm going to divide that by 2 times rad 21. Close my parentheses. Close my parentheses. Now, one of the nice things about TI-89 is if I punched in incorrectly, it will show me, okay, what I'm typing in. It will, otherwise, other calculators will not show you. You'll just get an answer, okay, and it might be right, it might not be right. All right. Now, I want you to notice I'm getting one undefined. Notice, like I told you, it will show you if I typed in right or not. Look, it's multiplying by rad 21. Where should the rad 21 be? Next to the 2 down there in the bottom, right? Okay, so that's why I'm getting that answer. So I just need to add 2 more parentheses here. Okay, 1 there, and that's what's so nice about TI-89. Okay, and then that should take care of it for me. And you'll see it in a second. See? We'll put it right there. Now I know I typed in correctly. Okay, so the angle C, therefore, turns out to be 11 degrees. Okay, so I have everything except angle B. So 120 plus 11 degrees is going to give me 131 degrees. So what's this going to be then? 49 is correct. Alright. Alright, 23, 24, and 25. Let's clear that out. Let's go to 23. 23. I have A is equal to 10, have B is equal to 8, and I got C is equal to 5. Okay, got some random triangle, not a right triangle. Okay, call that A, B, and C. 10, 8, and 5. I just have to find the other 2 angles. Because it's law of sines, it doesn't really matter if you find the large angle or not, because law of cosines. So I'm going to go ahead and find the largest angle. Okay, so that's going to give me, I'm going to use A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. Alright, A is 10, so 10 squared. B squared is 8, B is 8, so 8 squared. C is 5, so it'll be 5 squared minus 2 times 8 times 5 times cosine of angle A. Alright, this is 100, this is 64, this is 25, and that's going to give me 80 and cosine of angle A. This is 100, okay, and that's going to give me 89 minus 80 and cosine of angle A. Now, be careful, don't subtract 89 and 80. Okay, so I'm going to subtract 89 from the 100, which is going to give me 11 is equal to negative 80 over cosine of angle A. I'm going to get a negative 11 over 80 is equal to cosine of angle A, and that's going to give me A is equal to cosine inverse of negative 11 over 80. Okay, this is negative, so cosine is negative in the second quadrant, so obviously I'm going to get an angle that is bigger than 90 degrees. Okay, because it's going to be in the second quadrant. So I'm going to go to cosine inverse. So cosine inverse, I have a minus 11 and divide that by 80. close parentheses, approximate. There you go, 98 degrees. Okay, that's 98 degrees. Alright, as soon as I know an angle and a side across from that, I can go to law of sines. Okay, just make sure that that you line up everything correctly. So it doesn't matter which one you use. Let's go C. So sine of 98 degrees over 10 is to sine of C is to 5. Okay, so my I'm going to have sine of 98 degrees. So let's go sine of 98, and I'm going to divide that by 10. Okay, hit enter. Oops, approximate. Okay, that's going to be 0.099. Okay, I'm going to multiply that by 5, which is going to give me sine of C. So I'm going to go times 5, enter, which is going to give me 0.495 is equal to sine of C. And then we'll take sine inverse of that. So sine inverse of 0.495. Okay, and hit enter, and that C turns out to be 30 degrees. Okay. Alright, this is 30, and that's 98, that's 128. So what's that going to be then? There you go. It's done. Alright, 24. Okay, you have a lake. You don't know how wide that lake is, but you know there's a house here, okay, and there's a house on the other side of the lake, and you want to be able to measure the lake, okay, how wide the lake is. Well, you can use trig to do that. You don't have to necessarily, swim across the lake with the tape and measure it. Okay, so to do that, all we're going to do is, this is what you see on the roads, surveyors doing, is finding these angles. Okay, and let's say you're at some point. Okay, at that point, that's 50 foot from the first house, and then from the second house, that point is 70 feet. And then the angle between right here, this angle, let's say that is 70 degrees. Okay, now we can find how wide the lake is by using law of cosines. Okay, because I have an angle but I don't have a side across from that, so I have to go law of cosines. So let's call this A, call this B, call this C. Okay, that's a triangle. So I'm going to get, since I have angle A, I'm going to find A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. Plug in everything we have. So A squared is equal to 70 squared plus 50 squared minus 2 times 70 times 50 times cosine of angle 70. Okay, that's 49 and 2 zeros, and this is 25 and 2 zeros, and that's minus, that's 100 times 70, so that's 7 and 3 zeros. Okay, and then I have a cosine of 70 degrees, so I'm going to punch in cosine of 70. So cosine of 70, approximate that, and that turns out to be 0.342. I'm going to have to multiply these first, so my A squared is this, so I'm going to go ahead and multiply times, okay, 7,000. Okay, so I have this turns into a minus 2394.141, and I have 4,900. Okay, back it up. 0, 0 plus 2,500. Okay, and then I have a minus. Okay, 2, 3, 9, 4.141. Okay, so this is 4,900 plus 2,500. That's my a squared. So my a squared is approximately 5,005.859. So my a is going to be square root of that. So I'll go second square root. Let me get my answer. Second answer. Hit enter. And there it is. Approximately 70.752 feet. And there it is. All right, 25. I guess this is the hardest one. All right, 25. It says a Major League Baseball diamond is actually a square that is 90 feet on each side. So let's draw a square. And that's 90 feet, and that's 90 feet. Okay, we'll call this home plate, call this the first, and then we'll call this the second. Alright, and it says that pitching rubber is located 60.5 feet from the home plate. So go somewhere here, okay, and this distance right here, that's 60.5 feet. And on the line that connects the home plate to the second base, so it's in this line here, that's a diagonal of a square. That means this angle is 45 degrees. Okay, so I have a pitching mound right here, so since that's a diagonal of a square, it's going to be 45 degrees. Okay, question A, how far is it from the pitching rubber to the first base? So they want you to find this distance from here to here. We'll call that x. Right, we can use law of sines. No, we can't use law of sines. We got to use law of cosines, because I need an angle on a side across from that. So we've got to go law of cosines. Okay, so I do know this angle right here, and that means I can go x squared is equal to, I do know this side, which is 60.5 squared, plus this side, which happens to be 90 squared, minus 2 times 60.5 times 90 times cosine of 45 degrees. So my x squared is equal to, okay, 60.5, square that, and that is going to give me 3660.25. 90 squared is going to give me 81 and 2 zeros, and then I have a minus. I have a 2 times 60.5 times 90 times cosine, so cosine of 45 degrees. Okay, hit enter, and there it is. That's 700.393. Alright, so we're going to add, subtract all the way across. So I have a plus. Oops, no, I can't do that. Clear that out. So 3660.25 plus 8100 minus 77 0.393. Okay, hit enter. So my x squared turns out to be 4059.857. I'm going to take square root of that. Okay, so second square root of my answer. Okay, hit enter. So my x turns out to be 63.717 feet. Okay, so this is 63.717 feet. Okay, second question. How far is it from the pitching rubber to the second base? So we're going to find that distance right there. But if you notice, this right here is an isosceles right triangle. So I know both sides, so I can use Pythagorean Theorem to find this whole side, and after that I can just subtract away that. Okay, so let's go with a 90 squared plus 90 squared is equal to c squared, which is 8100 plus 8100 is equal to c squared, which is going to give me 00216 is equal to c squared, and my c is square root of, so square root of 16200. I don't like that. I want decimals. So my c turns out to be 127.279 feet. Okay, so that's this whole distance right there. To find that distance, I'm going to take 127.279, subtract 60.5. Okay, so when I subtract minus, okay, 60.5, hit enter, and this turns out to be 66.779 feet. Alright, last question. If the pitcher is facing the home plate, okay, through what angle must he turn to face the first base? So that means this is the angle we're trying to find. Okay, we can use law of sines now because we know that angle and we know a side across from that. We don't have to use law of cosines anymore. So we're going to go sine of 45 degrees is to 63.717 is equal to, we'll call this theta. Okay, so sine of theta, and the side across from that is 90, is equal to 90 feet. So sine of 45 degrees, sine of 45 degrees, and then I'm going to divide that by 63.717. Okay, I'm going to hit enter, and I'm going to multiply that by 90. Hit enter. So I have sine of theta is equal to 0.998 or 0.999 if I round up 3 decimal places. So to find my theta, I have to take sine inverse. Okay, sine inverse of 0.999. Okay, so let's take sine inverse, and I'm going to go second sine inverse of the answer that I had on the last part. So answer, okay, hit enter, and that turns out to be approximately 87 degrees. Okay, so 87 degrees. That's it. And then next year when we get to calculus, you have a problem Sarah's doing. Let's say you're at the first base, and the runner's running at 25 feet per second, going to second base. Okay, how fast is the distance between the runner and the home plate is changing? That tells you, okay, what your aim has to be able to take the runner out. Okay. All right. Same problem, just extended. Okay, that's it. So what about law of sines? Any questions on section 39? Olivia. Section 39. 14. Yes, Colby. 7. Yes, Brendan. 8. Stephanie. 9. Gosh, I thought this was the easy stuff. 13. Alright, let's start with 7. Okay. Number 7. I have A is equal to 3. I have B is equal to 2. And I have alpha, or A is equal, angle A is equal to 50 degrees. Alright. Notice, I'm given angle A, I'm given side A. That means this is going to be law of sines. Whenever you have law of sines, that means you could have ambiguous case. Okay? So you should set up your triangles this way. You don't have to, but it will make your life easy. Okay? So what I want to do is, I want to be able to call this angle A and call that 50 degrees. And then side across from that, we're going to call that 3. Okay, and then the B, the remaining side, put it over here on the top. So then we can go, that'll be B, that'll be my C. Okay, wherever the side you're given, put it over there on the top. The reason for it is, if I have a second triangle, I can swing this side over here. My angle still hasn't changed. My 2 hasn't changed. And this is still 3 because this is the same side as this, so that hasn't changed. So I could have a second triangle. Okay, but let's solve the big triangle, and then we can determine if I have 2 triangles. Or I could have no triangles. Alright, law of sines. Sine of 50 degrees is to 3, okay, is equal to sine of B is to 2. The reason I picked sine of B is because I have the side B. Okay, sine of 50. So sine of 50. Okay, and then divide that by 3. Okay, and approximate. And that turns into 0.255. And we'll multiply that by 2. It's going to give me sine of B. Okay, so times 2 is going to give me 0.511 is equal to sine of B, and I'm going to take sine inverse of my answer, and that turns into, my B turns into 31 degrees. Okay, so this is 31 degrees. Alright, so now that's 31 degrees. Now I know what this angle is. That's 50. That's 31. So this angle has to be 99 degrees. Soon as I know that's 99 degrees, I can solve for side C. So I'm going to use the same thing that I used here, okay, because I already have all the information, which is 0.255. So I'm going to go sine of 99 degrees is to side C is sine of 50 degrees is to, don't sleep on me there, Kevin. Okay, getting ready to curl up like a little puppy in a corner. Okay, so this is 0.255, and sine of 99 degrees is sine of 99 degrees is 0.987 over C. Okay, my C, obviously I'm going to have to cross multiply here and then divide that by 0.255. So my C turns out to be 0.987 divided by 0.255. Okay, so that's my answer. I'm going to divide my answer by 0.255. Hit enter. And my C turns out to be approximately 3.873. So this is 3.873. That's my triangle. But there's a possibility of a second triangle. You have to check. since this side here is exactly same as this side, so that's going to be 3. Since that angle is 31, that angle there is going to be 31 also. If that's 31, this is a supplementary angle. So what's 180 minus 31? Okay, 149. But remember, if I have a second triangle, these 3 angles here have to add up to 180. But already 149 plus 150 is bigger than 180, so I do not have a second triangle. Okay? And if you do, you have to go ahead and solve for the second one. Okay, let's go to 8. My 8, it says B is equal to 5, C is equal to 3, angle B is equal to 100 degrees. Again, I'm not going to draw it to scale. I'm going to put my B here. I'm going to call that 100 degrees. Okay, and that means that's going to be the 5, and that's going to be the 3. Okay, so that's going to be the angle C, that's going to be angle A. Alright, so law of sines, because I have an angle and I have a side across from it. So sine of 100 degrees is to 5, is to sine of C is to 3. So we're going to go sine of 100, okay, and divide that by 5. Okay, give me a decimal representation, which is 0.197. Multiply that by 3. This is my sine of C. So times 3, hit enter, is 0.591 is equal to sine of C. So my C is sine inverse of that. So I'm going to go sine inverse of the answer. One of the nice things about graphing calculator is you can bring everything back. Okay, and this is going to be 36 degrees. Alright, so that angle is 36 degrees. Okay, that's 100, that's 136, so what's my angle right there? 40 what? 3? 44. Alright, 44. As soon as I know that, since I already know this information here, I'm going to go ahead and use that. So sine of 44 degrees is to side A is to sine of 100 is to 5, and I already figured this out, that's 0.197, and sine of 44 degrees is what I have to figure out. Sine of 44, okay, give me a decimal representation of that. It's going to be 0.695 over A. So when I cross multiply this, my A is going to be 0.695 divided by 197. So I'm going to divide that by 0.197. Hit enter, and A turns out to be approximately 3.526. 3.526. Okay, I got checked for ambiguous case, so I'm going to rotate this side over to here. Okay, if that's 36, that's going to be 36 also. And if that's 36, then this angle here is going to be 144. Well, 100 and 144 is already too big, so I don't have a second triangle. Alright, let's go to number 9. Number 9. You have A is equal to 4, B is equal to 5, and angle A is equal to 60 degrees. Again, I want to set it up like this. Okay, whenever I'm using law of sines, so I want to go A here, give an angle there in that corner, only because it's easier to see, and that's 4. I'm going to put the 5 here, so if I can rotate the sides, I know what I'm doing. B, and that's C. Okay, that's going to be sine of 60 degrees is to 4 is equal to sine of B is to 5. So sine of 60 degrees, okay, it's actually read 3 over 2, but we need decimals, so let's go sine of 60, and we're going to divide that by 4. Decimal representation of it is 0.216 or 217, and we're going to multiply that by 5, which is my sine of B. So we're going to times that by 5, and that's going to give me 1.08 sine of B. Game over. Why is the game over? Can't be greater than 1. So I have no solution, no triangle. Okay. All right. 13. Height of a plane of an aircraft flies, and they give you a picture of this in the next page. Okay, so let's just go ahead, jump right to the diagram, and they tell you Sam's located here and Katie's located there, and the distance from Sam and Katie is 1,000 feet. Okay, and then the height, that you have a plane somewhere up here in the middle. Okay. And they tell you they find this is to be 40 degrees. From Sam to the plane is 40 degrees. From Kate to the plane is 35 degrees. Okay. And they want to know how high is the plane. Okay. First of all, if you know this is 40 and this is 35, you know what that angle is. And what is that angle? What? 105. 105 is right. Okay. We're trying to find this. But we can't find that unless we solve one of these right triangles. So you got to figure out which one you want to. It doesn't matter. You can solve it either for this side. We'll call that side S. Or we can solve for this side. We'll call that side K. Because this is 90 degrees. Okay. So which way do you want me to go? S. Okay. So to find sine S, we know this is sine of 105 degrees is to 1,000 is equal to sine of 40 degrees is to S. Alright, so let's go ahead and find out what sine of 105 degrees is and divide that by 1000, and then get a decimal representation. That's 9.659 is equal to sine of 40. Did I do something wrong? .0096. Oh, you're right. Sorry, I didn't see that E. Thanks for catching. I won't say anything bad about you ever again, Brendan. At least this week, anyway. Okay, that E right there. Okay, I had to. You got to be careful because some of you do not know how to interpret that E. So one of the students in this class, I had to dumb it down. Okay, one way to dumb it down is this calculator is go to mode. Okay, instead of float. Okay, for calculus I need float, but I need you can just fix it. Okay, and fix 10 places. Hit enter, and I'll do it again. And look what happens when I do that. Okay, sine of 105. Okay, divide by 1,000. Okay, and that will give me that. Yes. No, that's not for right triangle. I'm solving for the big triangle. I haven't got to the right triangle yet. I got. Okay, so this is 0.00965. Okay, so might as well 0.965. And sine of 40 degrees. Sine of 40 degrees. Okay, and that turns out to be 0.6427, or just make that 643. 3 decimal places is fine whenever you can. All that over S. So when I cross multiply, my S turns out to be 0.643 divided by 0.000965. So we're going to divide that by 0.000965 and hit enter. And this turns out to be the devil's number, 666. Alright. You know what they say, the devil's in details, right? Alright, now I have a right triangle. I can use the right triangle and solve this height. So it's going to be, I can just go, this is my hypotenuse right here. And this is my opposite side of this triangle. And it's a right triangle. So sine of, oops, come on. Okay, sine of 35 degrees, okay, is opposite, which is h, over hypotenuse, which is 666. So my h is 666 times sine of 35 degrees. So we're going to go to our handy dandy calculator. Sine of 35 degrees, okay, multiply that by 666, hit enter. It's a good decimal representation of that. So the height is 382 feet. That's how high the plane is. What's that? Yeah, if they're getting ready to shoot you down, they'd find that low. Yes. Well, you should try to round off anywhere. Anytime you're rounding, you round off to 3 decimal places as you go. But I'm checking for your work, so not everyone's going to have exactly the same answer. Okay. But it better be close, or in that area. This better not be like 1,382 feet. Okay, got that, Brendan? Okay. Okay, number 14. All right, they give us a ski lift, and it looks like this. They tell us this is my C, this is my point A, and I have point B right there, and they say this is point D, and that distance is 1,000. Wait a minute. Proposal made ski lift A to B. Okay. So this is my ski lift A to B, okay, and DAB, so this angle here is 25 degrees, and this angle here is 15 degrees, and he then walks 1,000 feet from A to C, so that's 1,000 feet there. Okay, what is the length of the lift from A to B? Okay, so we're trying to find this distance, A to B. Okay, and this is 25 degrees, so we know what that angle is. So What's 180 minus 25? 155. Okay. Alright, so we know that's 155. Then if that's 155 and this is 15, that's 60, 70. So what is that angle right there? 10. Okay, now we needed that angle because we're going to use this 1,000 feet. We're going to use law of sines. So sine of 10 degrees is to 1,000. And we're trying to find this distance. This is my C. So sine of 15 degrees is to side C. Okay, so let's go ahead and find sine of 10 degrees, and then we're going to divide that by 1,000. Okay, hit enter, and this turns out to be 0.000174 is equal to sine of 15. Let's go find sine of 15. Okay, hit enter, and that's 0.259 over C. So if I want to solve for C, my C is 0.259 divided by 0.000174. So I'm going to divide that by 0.000174 and hit enter, and that turns out to be 1,487.466 feet. Okay, it's 1,487.466 feet. That's it. Okay, law of sines, law of cosines. Good news. We're done with trick.